have discussed about the Bernoulli's principle. Actually, what is the statement of the Bernoulli's principle? When a ideal fluid flow in a pipe of very cross-sectional area, then the total energy of the fluid at any point remains constant. Total energy means pressure energy, kinetic energy, and plus potential energy. Is that clear?
Yes, sir.
But the condition is that the fluid should be in streamline flow. So just suppose that there is a pipe of very cross-sectional area like this. Okay.
Yes, sir.
There are many ways to prove the Bernoulli's principle, but I am going to use the work energy theorem. Okay. So by using work energy theorem, we will prove to Bernoulli's principle. Okay. Last time we have already discussed about the what Bernoulli's principle. Okay. So first of all, let's suppose there is a fluid flowing in a pipe of very cross-sectional area between point A and B. Suppose that the fluid initially at these 2 points. Is that clear?
Yes.
Just suppose that cross-sectional area of the pipe at point A. Cross-sectional area of the pipe at point A is equal to A. The cross-sectional area of the pipe at point A is A1. Is it? Is that clear? And cross-sectional area at the point of the pipe B is A2. And at point B is equal to
A2.
Is that clear? Let's suppose velocity of the fluid at point A is V1. Velocity of fluid at A is V1. And at point B is V2. Is that clear?
Yes.
The direction of the flow of the fluid is just upward direction. Is that clear? And at point B is
V2.
Is that clear?
Yes, sir.
Then you know that every point there will be the total energy of the fluid. That means there will be pressure energy, there will be kinetic energy, and there will be potential energy. Let's suppose to determine the potential energy, suppose height of the point A from ground is h1 and the height of the point B from ground level is
H2.
Is that clear?
Yes, sir.
Now suppose that that means there is fluid flowing in the pipe. Then that means there will be a pressure exerted by the fluid and on the fluid. Just suppose that the pressure at this point is P1 and it will be forward direction. It will be forward direction. Pressure, yeah, fluid flow. You can assume it is fluid pressure. Fluid pressure at A. It is P1. And it is forward direction. What? Forward direction. Is that clear? Now, let's suppose at point B, the pressure. What will the direction? Fluid pressure at B is equal to P2. What will the direction of the P2? We are just studying about this fluid. So from this point, some fluid will flow from forward direction, some fluid is flowing in forward direction. That means the direction of the pressure on fluid is forward direction. And at this point, the pressure will be backward direction, something like this. Is that clear?
Yes, sir.
Is it?
Yes.
And fluid pressure P2 and it will be backward direction. Direction. Is that clear?
Yes, sir.
Now, we have to calculate the work done by the pressure energy. Now next, now we have to calculate the work done by the pressure energy. Now first of all we have I have to calculate the force applied by the P1. Then force applied by the P1, it will be what better? It is P1 A1. P1 A1. Why? Actually the pressure is equal to force upon area. Is it? Then F will be P into A, and at point A the pressure, fluid pressure is P1 and the cross sectional area is A1. That's why I have written P1 A1. Obviously it will be forward direction. It will be forward direction. Is that clear? Now second thing, force applied by the P2. What will the force applied by the P2?
P2A2.
P2 A2. Is that clear? It will be backward direction. Okay. Now it is very simple to calculate the work done by the pressure. Now how we can calculate the work done by the P1? Just suppose that in delta T time the fluid which is at point A will be moved at point A2. Suppose like that. Is that clear? It is displacement of the fluid at point A in time delta T, and it is point A dash. Is that clear? Then what will the distance? Actually the velocity is V1, then the displacement will be V1 delta T. How? Displacement equal to velocity into time. Is it? And what will the displacement of the fluid which is at point B? It will be moved, suppose that at this point. And it is point B dash. Is that clear?
Yes, sir.
And this displacement will be
V2 delta T.
V2 delta T. That's good. Is that clear? So work done by P1 will be what? P1 A1 into displacement, and displacement is V1 delta T.
Yes, sir.
Is that clear?
Yes, sir.
And work done by, suppose it is W1. Just suppose that it is W1. What is W1? Work done by P1.
P1.
Is that clear?
Yes, sir.
And work done by
V2.
P2. It is W2.
W2.
And it will be
P2 A2.
A2
V2
V2.
delta T.
Is that clear?
Yes, sir.
Any doubt?
No.
Now, last time we had discussed about the equation of continuity. Equation of continuity. Just suppose that what will the mass of the this fluid? Mass of fluid between A dash. What it will be? Suppose that delta M1. And how you will calculate it? Density of the fluid
Density upon
and volume. Is it? Density into volume. Now suppose that density of the fluid is rho. It is rho. And what will the volume be? Exactly. Cross sectional area into this length. That's mean A1 V1 delta T. This is delta M. Is that clear? Similarly you can say that Similarly, we can just use similarly mass of fluid between
B and B dash.
B dash
B dash.
it will be delta
M2.
M2 equal to rho
A2.
A2
V2.
V2
Delta T.
Now just have a look bete. Can you calculate the value of the A1 V1 delta T from this relation? Just use A1 V1 delta T will become delta M1 upon
Rho.
as similar this one. Then you can say that W1, that means work done by pressure P1, it will be what? Just it will be delta M upon rho. Is it? So just put the value. W1 will become P1 delta M1 upon rho, and W2 will be what?
P2 delta M2 upon rho.
P2 delta M2 upon rho. Is it? Now net work done by the pressure energy. Net work done by pressure energy. Pressure
Energy.
energy. It will be what? Just have a look bete. P1 is acting on forward direction and P2 is acting on backward direction. That means the work done by the P1 will be positive and work done by the P2 will be negative. That means it will be W is equal to W1 minus W2. Is it? And it will become what? You can denote it work done by pressure, that is WP. Okay. W1 will become P1 delta M1 upon rho minus P2 delta M2 upon rho. Is it?
Yes.
Got it? Suppose that it is equation number 1.
One.
It is work done by pressure energy. Work done by.
Pressure energy.
Now we have to calculate the work done by the. Let's first of all calculate the work done by the potential energy.
Okay, sir.
See better. Now, how you will calculate the work done by the potential energy? Suppose that, as you know that, do you remember that during the work energy theorem we had discussed that work done by the conservative force is negative, negative change in potential energy, negative gradient of potential energy. Have you remembered? No. That's meaning you can say that the work done, actually the what is work done by the potential energy, that means it is, as you know that gravity is a conservative force. We have discussed it. Do you know what is conservative force? Yeah. Conservative force is one which better whose work done does not depend on the path followed by the object. Okay.
Yes, sir.
है ना? दैट्स मीन है कि कंजर्वेटिव फोर्स होता है जो जहां पे क्या करता है, जो वर्क डन है वो किस पे डिपेंड नहीं करता है, पाथ पे डिपेंड नहीं करता है. दैट्स मीन कि वर्क डन बाय, इफ वर्क डन बाय द फोर्स डज नॉट डिपेंड ऑन पाथ, देन द फोर्स इज सेड टू बी कंजर्वेटिव फोर्स. सो फर्स्ट ऑफ ऑल वी विल calculate the change in potential energy. What will the change in potential energy? Change in potential energy. Potential energy. Is it? See, at this point, potential energy, it is actually S1 there. At this point, the fluid, the potential energy of the fluid will be what? mgh.
Yes, sir.
And it is actually delta m1.
Yes, sir.
G, that's when gravity, acceleration due to gravity, and h1.
H1.
And at this point, it will be
Delta M2.
delta m2 g
G. H2.
So what will the change in potential energy? This energy minus this energy.
Yes, sir.
Change in potential energy is delta M2 G H2 minus
Delta
delta M1 G
H1.
It is actually what change in potential energy. So you can denote it by delta U.
U.
Okay. Now again I am repeating same thing. The work done by the conservative force is negative gradient of the change in negative gradient of potential. That's meaning the negative change in potential energy. So work done by the gravitational. That's when potential energy will be work done by potential energy. Potential energy will be what? It will be WP. I am denoting work done by potential energy is negative change in potential energy. Is it? Now, how you will calculate it? WP is equal to negative change in potential energy, and it will become this minus this. That means delta M1 G H1 minus delta M2 G H2. Is it? And it is equation number 6. Now I am going to apply the work energy theorem. But before this, I have to calculate the change in kinetic energy. What? Change in kinetic energy. So let's calculate the change in kinetic energy. But actually, I have not sufficient space to calculate the change in potential energy. So first of all, you can note this one, and then I will rub this. Then we will move forward. Okay, but listen. Now, this is work done by the gravity. We have to work done by the weight or work done by potential energy. Just have a look at it. Just see. Now then, I am going to calculate the change in kinetic energy. Change in kinetic energy. Just suppose that bit. As you can see, the mass of this portion is delta m1 and velocity is v1. So what will be the kinetic energy at this point? It is half delta m1 into what? v1 square. And of this fluid, it is
half M2 V2 plus 1.
v2 square. Is that clear?
Yes.
So change in kinetic energy is delta ek. That's means change in kinetic energy, and it is 1/2 delta m2 v2 square minus 1/2 delta m2 v1 square. Is it? Now, according to the work energy theorem, you have already know what is work energy theorem. Yes, Samir. Do you know what is work energy theorem? Work energy theorem. According to
total work done equals to change in
according to work energy theorem, what it is?
total work done equals to change in kinetic energy.
Total work done is change in kinetic energy. The work energy theorem is total work done is equal to change in kinetic energy. So change in kinetic energy is this one. That means change in kinetic energy is equal to total work done, and it is what? Work done by the pressure energy and work done by the weight, or okay, and it is work done by potential energy is WP plus WP. Okay, there is a problem. Okay, so we can use this different symbol for both. Okay, suppose that it is P1 and it is P2. Okay, so it is work done by pressure energy and work done by potential energy or work done by gravity. Okay, so it will be equal to what is change in kinetic energy? Change in kinetic energy is 1/2 delta m2 v2 square minus 1/2 delta m1 V1 square
V1 square.
is equal to what is delta work done by pressure energy? It is P1 delta M1 upon rho minus P2 delta M2 upon rho plus it will be delta M1 GH1 minus delta M2 GH2. Is it?
Yes, sir.
Now, have a look at it. Just shift the all P1 M1 terms one side and put the all two terms another side. So just shift to this term in this side and like this. Then you will get that 1 upon 2 delta M2 V2 square plus what? Plus P2 delta M2 upon rho plus delta M2 GH2 is equal to
1 upon
see bete P1 delta M1 is already here upon rho
yes, sir.
and this term will shift to this side, then it will become plus 1 upon 2 delta M1 V1 square and already delta M1 GH1 is here. Is that clear? Please pause. According to the conservation of mass, delta M1 is equal to delta M2. Is it? Delta M1 equal to delta M2. So just put the delta M in the place of delta M1 and M2. So you will get 1 upon 2 delta M V2 square plus P2 delta M upon rho plus delta M GH2 is equal to P2 delta M upon rho plus 1 upon 2 delta M V1 square plus delta M GH1. Is that clear? Now divide the whole term by rho upon delta M. Rho upon delta, it will divide to this term by rho upon delta M, then you will get 1 upon 2 rho V2 square plus you will get P2 plus you will get rho GH2 and it will become here P2 plus 1 upon 2 rho V1 square plus it will become what? Rho GH1. Just have a look at it. It is what? Kinetic energy per unit volume at point B. Okay? And P2 what? Pressure energy at point B. And it is what? Potential energy at point B is equal to potential energy at this point, kinetic energy per unit volume at this point, and potential energy per unit volume at this point. That means you can say that pressure energy, kinetic energy and the potential energy during the streamline flow in a varying cross-sectional area pipe is remains constant. That means you can say that is P plus 1 upon 2 rho V square plus rho GH is remains constant, and it is proof of the Bernoulli's principle. Okay, is that clear?